stars and seeing these fascinating shapes. Well, I started my career working with the infinity of space and handling the enormous amount of data that it can produce. But although I graduated as an astronomer, I switched to a career as a data scientist. But I guess I couldn't say goodbye to the visually focused astronomer inside of me, because I found myself loving the visualization of the data even more than the analysis itself. So I switched gears, and I'm now a data visualization designer working for Agen during the day, while at night I create personal projects, experiment with new ideas, or write tutorials for my website. And I found that in data visualization, I tend to be a perfectionist. I love spending hours and hours on some small details and make it exactly as I have in mind. While being born and raised in the Netherlands, I always willfully hope that maybe my craving for perfectionism stems from the same genes as those of the Dutch master painters who managed to put such a dedication to detail into their artworks. But although painting and data visualization isn't exactly the same thing, I do always start my visuals on plain paper. And once I have a mental image of how something should look, the computer had damn well be able to create some semblance of it on the screen for me. However, usually what I have in mind isn't quite the default setting or what all of the examples are using, and it forces me to try and be creative and think outside of the box to try and recreate my concept. But you'd be surprised by the results if you try to experiment with the norm, use things in an unconventional manner, or use elements from different fields of design to create a more effective or fun visualization. Okay, so we're almost ready to take off and go beyond the shapes, but first let me explain how SVGs fit into the world of D3, which is a JavaScript library that has become the standard for online data visualization, and is what I'm using for all of the examples in my presentation. So once you start working with D3, you quickly figure out that its basic building blocks, its shapes, are SVGs. And by bringing these shapes, these rectangles and paths and circles and lines together, you can create some awesome visualizations. And I'd like to take you along on my journey on how I started using SVGs beyond their mere shapes. So my first step beyond the shapes came when I was trying to create a color legend. And I was looking for a way to have a legend that would go smoothly through all of the colors that I was using. And that's how I got into Svg Gradients. See, the thing was, it wasn't really necessary to read off the exact value that each color represented. It was more about seeing trends and getting an overall sense of the numbers. Like in a heat map, for example. Well, this one shows the number of traffic accidents that occurred during a year, and then we have day of the week on vertical, and then hour of the day on the horizontal. And the darker the color, the more accidents that occurred. So no surprise that most traffic accidents occur during the morning and especially the evening rush hour. And here it's really about these trends. It doesn't really matter if it was 1,470 or 1,520 accidents. And the legend below what you see is what I mean with having a smooth legend that goes through all of my colors. And it's nothing more than a simple SVG rectangle filled with a linear gradient. And because I have a few more gradient examples coming up, I'll first quickly explain how you can create one based in the code of D3. So there actually exists a linear gradient element, but you have to nest that within a defs element, and defs is short for definitions, and it contains special things such as gradients, but also filters. And it's very important that you give your gradient a unique ID so that you can reference it again later on when you want to apply it to an element. So then we have to supply the direction. So along what angle will that gradient run across my shape? And you do this in a similar way as an SVG line. So we have a starting point with x1, y1, and then we have an end point with x2, y2. And then both of these sort of create a directional arrow that will define the direction of your gradient. And by playing around with these values, so for example, a horizontal gradient will have x1 at 0% and then x2 at 100%, because you can supply these values in both percentages with respect to your shape and exact pixel locations. And then both y's, because it's horizontal, can be the same, so 0% is fine. And you can make it vertical if you want to, or any angle that you like. Although what I'm showing here isn't quite correct, because it really is the bounding box. So the smallest rectangle that can enclose the entire shape that defines where these starting and ending positions lie. And that means that in this case, a 0% starting point really lies outside of that visible shape. And that means that once that gradient starts coming into the shape, it's already turned slightly more purple. And maybe you don't want that, and that's fine. You don't have to start at 0 and end at 100. You can fill in whatever numbers that you like, and then the region outside of that gradient, that directional arrow, will be filled with whatever color was there on the outer sides. But we are just going to use a normal horizontal gradient. And after supplying the direction, all that's left to do is supply it with some color information. And for this, the stop element exists. And you supply the stop element with a color, the stop color, and an offset. And the offset is the location along that directional arrow where that color should become pure. So here I've applied or appended a light blue color all the way at the start at 0%. And now I'm going to apply another color, because otherwise it wouldn't be a gradient, of a darker blue color at the other end at 100%. And now the gradient is ready, it can be used. So what we do is we grab that rectangle, and then we set its fill style by referencing that unique ID that we gave the gradient before. And this is the result that we get. Well, if you have many colors in your gradient, it might become tedious to keep appending these stops. Well, luckily we can use D3's data step to make that process quicker. So let's go back to that linear gradient right after setting its horizontal direction. And now I'm going to supply it with a data set that contains the offset and the color for all of the colors. And then D3 will create a stop element for each of these. And then I need 2 more lines to set the stop and the offset. And D3 will just fill that in by using the data that is now attached to the gradient. And just to show you, if you want these colors to be evenly spread out, you can do it in even less lines of code, because then we only really need to supply the colors themselves. And we can calculate the offset by using the index of the color in the array and the array's length. So just to show you a bit of how D3 code really works. Well, here's another example that is, in essence, a heat map and can thus be combined with a smooth legend. And it's the visual output of a machine learning technique used to cluster data called self-organizing maps. And it's what started my love for hexagons. And I wish I could say I was using the color palette that's visible right now, but I started using this technique before I really was into data visualization. And I do come from a science background, so my go-to color palette was a rainbow, of course, which I've since come to understand is a big no-no in data visualization for continuous data. Well, nevertheless, people do like the rainbow palette, so staying in that mood just a bit longer. Here we have one of my favorite temperature visualizations. And I recreated a weather radial for New York in 2015. And what you see here is 365 little bars going from the minimum temperature to the maximum temperature measured on that day, and it's colored according to the average temperature. And here it's really also about seeing trends. When was it really cold? When was it really hot? So again, we have a smooth legend to display these numbers. Well, being an astronomer, I of course wanted to make a visualization about exoplanets, which are planets that lie outside our solar system. And my setup was to do a bit of data storytelling to explain how weird and amazing these planets really were. But to make these circles all rotating around one generic star a bit more than, well, flat circles, I turned them into tiny spheres by using a radial gradient. And I made, well, that's actually the second option that you have besides the linear gradient. But I made a unique gradient for each of these planets because I wanted to base the color on the planet's data. Well, creating data-based gradients is also very straightforward with D3 because we can use the data step in the same way as we did in the legend case. However, this time we immediately penned our planet's data set to the depth element so that D3 will create multiple radial gradients, one for each planet. It's still very important that you give your gradient a unique ID so that you can connect it to the right circle later on. And afterwards, we can use the data that is now connected to each of these radial gradients to set something like the base color of the circle. And then we can make it lighter on the inside and darker on the outside, move that center location a bit, increase the directional arrow, and now we have something that sort of mimics a 3D sphere. And if you then look in the DevTools, you'd see you'd have many radial gradients, one for each planet, and each of them would be slightly different. And finally, we select our planets, our circles, and we connect them to the right gradient. Well, instead of showing you a visualization of exoplanets, about which many have been made actually, I thought I'd show you what I think is one of the most important plots in astronomy. It's a Hertzsprung-Russell diagram. And here we have not planets, but we have stars, some of our nearest stars. We have luminosity on the vertical scale and temperature on the horizontal scale. But it actually goes from the hottest blue stars to the coolest red stars. That's due to historical reasons. And I once read that the first of its kind may well have been the very first scatter plot ever made, which I think is kind of cool. And we have our sun right over there. And these stars in the upper portion, Betelgeuse and Antares, they are indeed bigger. But if I were to scale them correctly, they would look more like this. However, that doesn't really create a very readable plot, so that's why a more powerful downscaling is added. Also, stars are, of course, the things that shine. They are not shined upon, so by tweaking that radial gradient a bit, you can make them look a bit more like the glowing orbs that they are. And another reason why I really like this plot, besides the amazing number of astronomical insights that have been found from it, is that I think there's very little visual encoding done. I mean, stars, they are round and they are visible to us in these colors, so it's like you're plotting the things themselves. And I personally don't know of a better subject to use for scatter plots than stars and planets, but I might be biased. So besides using data to set the color of a gradient, you can use it for practically all the attributes, such as the direction along which a gradient should run. Well, after watching the second Avengers movie, I was interested to find out how all of these Avengers were connected. So how often had they appeared in the same movie together? And I thought that D3's chord layout would lend itself nicely. So here we have the result with the original Avengers. And the thicker a chord, which are these inner lines, the thicker that chord, the more movies they've appeared in together. And by default, these chords are given one color. However, for this particular data set, that doesn't really work because the connections are symmetrical. Since if Thor appeared in a movie together with Hawkeye, then the reverse is true as well. So I wanted to do something else. And I can make them all gray. That's a bit boring. So instead, I wanted to fill the chords with a gradient that runs from the color of one Avenger to the color of the Avenger at the other side. And to pull that off, let's focus on Black Widow here. So for these 5 chords, I want to create 5 unique gradients that run across the directional arrows that are visible now to mimic the idea of it running across a chord, and then with the start and end color as given by the small circles. So something like this, but then inside of the chords. Well, one of the many nice things about D3 is that it helps you prepare your data for whatever chart type that you want to use. So you supply your data, and D3's functions will transform that into paths and rectangles and, not rectangles, but angles and widths. So it's things that you need to draw SVG shapes. And for this particular layout, it returns an array that contains everything that you need to draw these chords. And it's usually given the name chord.chords. So what we do here, as in the planets example, is immediately append our data set of chords to the linear gradient so that D3 will create a gradient for each of your chords. And one thing I wanted to point out here is that this is one of those cases where it is actually better to not use the bounding box of each chord to set the direction, but use the coordinate system that was already in place with its origin right in the center of the circle. And you can make that switch by setting the gradient units to user space unused. And the reason is that it's actually much easier to find the exact pixel locations of these 2 colored circles by using the data that is available in that chords data set, together with some sines and cosines. So it's useful that you learned that in math. So after setting these directions based on the chords data, all that's left to do is supply it with 2 color stubs. One at the source, that's colored according to the Avenger at the source, so at 0%, and then one at 100% that's colored according to the Avenger at the other side. And with those changes implemented, we get the following result, where each chord is now a representation of both the Avengers that it links. Well, you can also use gradients as something that is abruptly going from one color to another. It doesn't always have to go smoothly. And many very fascinating analyses of baby names have been done in the past, such as the most trendy or poisoned or unisex name. But I was interested in something much more simple. I just wanted to know how had the top 10 baby names risen and fallen from fame in the last years. And I was surprised to find out that the data available actually goes back to 1880. But a typical screen isn't really wide enough to do justice to 135 years of volatile change. So that's why I used the focus and context technique. in which you have a small chart below that highlights all of your years. And then you have a big chart. Well, you can select a small window from that. And that sort of the big chart above shows you what you've selected down below. And you can make the window bigger if you want to see more at the same time, or less. And so each of the lines here is a name, and the thickness is sort of the highest position that name ever reached, and the color is the starting letter of that name. And to make the connection between this sort of mini window and that bigger chart more clear, I wanted to color the mini chart exactly the same as the big one, but only for the selected region. However, you can only stroke a line with one color. And I didn't want to have to cut these lines up into 3 sections, so one before, one within, and then one after the selected window, and then have to update this dynamically as a person moved that window. So instead I thought, well, maybe I can use gradients for that. Turns out I could. So how to do this? Well, we have a gray stop. We first append a gray stop at some percentage, so let's say 40. But we give it a class left. Then we append a colored stop at exactly the same location, also at 40%. We also give that a class left. And now we already have that abrupt color change that happens at 40%. And then at some higher percentage, say 60%, we do the same, but in reverse order. So we first append a colored stop, and then a gray stop. We give these a class right. So now we have something that is very abrupt, and if I were to draw a rectangle, it seems as if we have 3 rectangles, where really it's just one with a gradient. And then you have to update these percentages when somebody moves that window, and some form of update function is called. And then this window seems to move right along with the window, so the colored region seems to move right along. So it's just updating these percentages. Well, using these abrupt color changes can also be very handy for showing categories. So here we have the trend of the mean body mass index over the past 40 years for a whole bunch of countries. And although not so black and white in real life, according to health standards, you have become overweight when your BMI comes above 25, and you're obese when it's above 30. And usually how that is displayed, these sort of different categories in a line chart, is then coloring the region behind that chart. So this region would be gray here, and then this region would be orange. But I sometimes find that to be too obvious, too intrusive. So instead, I try to fill the lines with a gradient that follows these same lines. That makes the focus more on this rising trend instead of this big amount of color that is behind the chart. And it's also very handy. Well, it doesn't matter if your data changes. So now we see men, but if I go to women, I mean, the gradient stays in the same location. So these lines, they are really moving on top of that gradient. So I was pleasantly surprised to find out that gradients can also be animated. And during a fun project at my previous employer, Deloitte, we had access to a data set that contained information about what education people had done and what occupation they ended up doing a year and a half after their graduation. And we wanted to visualize these flows from education to occupation. And I could have used a Sankey diagram, which is very good at showing flows, but the final visual was meant to be used in the media. So I wanted to try and create something that was a bit more eye-catching, and I have a love for circular things. So instead, I went to the chord diagram again, and with some hacking and tweaking and wrangling, turned it into more of a circular Sankey. Although when I shared the final visual online on Twitter, some people referred to it as the bad plot, which I thought was kind of catchy. So better than stretch chord diagram. Well, here's the final result, where we have educations on the left and then occupations on the right. But I wanted to have this flow from left to right be more obvious. So that's why I filled the chords with an animated gradient. Yeah, okay, that's visible. An animated gradient so that if you look at it, you know that there's something going on there from educations to occupations, but not too much in your face. So how to animate a gradient if this is unfamiliar for you? Well, during the creation of a normal horizontal gradient, you have to set one extra attribute, and that is the spread method, which defaults to padding. You have to set that to reflect instead. And with padding, what we've seen before is that the color outside of this directional arrow is just padded up with the colors that were there at the outer edges. Whereas reflect will create copies of your gradient in a mirror-like fashion. And then we have to move this directional arrow across that rectangle in a continuous way. And there are a few ways to do that, but I feel that code-wise the easiest to explain is by using an animate. So the animate grabs a hold of the x1 attributes, that's the starting point of that directional arrow, moves it from 0 to 100% in 7 seconds, and do that indefinitely. And because x2 is still fixed on 100% and that reflects, we get this sort of psychedelic result that's going on right now. So we grab a hold of that x2 attribute and move that from 100 to 200% so that we always have 100% of difference between these two lines. And then you have something that seems to be moving on in a forever fashion, even though it is actually reset every 7 seconds. Well, animating a gradient also gave me an excuse to put one of the most famous data visualizations ever made in my presentation. So here we have a recreation of Menards Map from 1896. And it's about the enormous losses suffered by Napoleon's army in his march to and from Moscow in 1812. So what we see here is the movement of the troops across the land past cities and rivers to Moscow in brown, and then back again towards France in black. And the thickness is the number of troops still alive, and the small line chart below it shows the devastatingly low temperatures that the troops had to face on their march back. And what I did was, when I first saw this plot, I found it a bit weird to understand. So I filled in an animated gradient showing this movement of the troops a bit more clear. So brown is towards Moscow and back, black is back again. And I also find it very sad to see every time that out of the 422,000 men that started this campaign, so almost 500,000, only 10,000 made it back alive. So Menard really made this map to show the futility of war. Well, leaving SVG gradients behind, we're finally entering the domain of SVG filters. And to be honest, we're also sort of leaving the realm of effectiveness in a visual behind a bit and going more into experimenting to have or create a bit of fun in your visual. So creating a filter starts out very similar to a gradient. This time we append a filter element to the depths and we still have to give it some unique ID. And then after that comes the magic part, where a specific combination of filters can create a result that you might have never expected. But the good thing is that usually you can copy this piece of code from visual to visual and you don't have to make any changes if you don't want to. Finally, if you want to apply the filter, select your element and set the filter style by referencing that unique ID. So the first one is rather subtle, but it can have a nice added effect in the right circumstances. Some people love radar charts and other people hate them. I'm personally not part of the latter group. They're circular after all. And a few months ago I made a redesign of a radar chart in D3. And although I was fine with it like this, I remembered coming across the code for some text or drop shadow or something, and I thought, well, that might make this a bit more engaging too. So I'll show you the glow. It's very subtle. I hope you can see it on the screen, sort of. And that was it, and it really depends on taste whether you prefer this or not. But what happens is fairly simple. Say we apply the filter to a circle, then it creates a blurred version of that circle. It pastes the actual sharp one back on top of it, and then we have the appearance of a glow. And it can be applied to SVG rectangles and paths and circles, so with a bit of glow. And one other occasion when I found that this just had that nice touch of detail was when I was playing around with spirographs, which I used to love as a kid. And I felt that with a bit of glow, hope that's visible, it just lifts it off the page a bit, makes it a bit more neon to look at. So with the glow and without the glow, it's a really small dedication to detail. Well, another effect that is very interesting and very subtle has to do with motion blur. And the faster and closer to us things move, the more blurred they appear. And with the right filter, we can recreate this effect on the screen as well. These circles, for example, the faster they move, the more blurred I make them to give them that feeling of fast movement. And I first came across this filter when I saw images being blurred when they moved across the screen in an image gallery. And I thought, well, data visualization often shows movement, so I wanted to see what I could do with that. And it's one of the most simple filters there is actually, because it creates a blur of your object in only one direction, so either X or Y. So here you have an example. These filters are now moving without a blur, but with a bit of an exaggerated blur we get this. So no blur and with the blur. So it's also very small, and I kind of like the fact that it makes it a bit more imperfect, makes it a bit more real or animated, I guess. So how to apply, I thought for a data visualization example, what about the top running speeds of some animals and the fastest human? So I'm going to move these circles outward to their top running speeds, and when they do, I am going to blur them. But you're probably not really aware of that. If I show you the two versions, you would notice it, but it's really just something that is subconsciously happening. So let me pull these circles back in, and I'll show you the blur that was really going on. So the cheetah is the fastest, so it gets the most blur. But then I sort of dynamically calculate how much blur the other animals and Usain Bolt has to get in comparison to the cheetah. And just to show you that it's possible, if you want, you can use images as well. These filters will apply to images as well. So if I move these images outwards, they are blurred as well. So really, it's really about these small things, dedications to detail that I can spend hours on. So my favorite filter, the GUI effect. And I first came across this filter when I saw a really nice loading demo for a loading button. And for the Deloitte Ladies Open, which is a golf tournament, visitors could do a golf clinic, and then we'd visualize the results. And to show how far the ball had gotten, I could just sort of make the data points appear on the screen like this. But I felt that was a bit boring. So instead I thought, well, maybe I can mimic the golf swing and let them fly out from 0. Well, that was better, but I wasn't feeling it yet. And then I remembered that GUI effect. And with this small change, the ball now seems to be ejected from the start as if it is trying to acknowledge the effort that the participant was making in trying to get this ball as far as possible. So it didn't make the visual any more true or false, but it did make it a lot more fun to look at for both me and the visitors. I'm not even going to try and explain how this filter works. I only understand about half of the steps. But besides this nice GUI effect, it has some wonderful color blending going on as well. And thinking more about how to apply that in data visualization. Well, for example, if you want to plot points on a map, maybe you can make it more interesting if you let them fly out from some center point to their final destination. And here we have the 150 largest cities in the world and size to their population. Or instead, if you want to group these back on a country level, then once they come into their countries, they form one country blob again. And these countries all together reminded me of a very fun example by Mike Bostock, which sadly never really, it does work. Oh, well, it works now. But with a bit of added goo, I find it even more fun to play with. It's like stuff your mother didn't want you to play with because your clothes would get filthy or something. Well, anyway. Time for the final example. And this one has to do with those wonderful color blending effects where two colors overlapping each other can create an entirely different color. And I first tried to recreate this effect using SVG filters until after some tinkering I came across that could be done with one line of CSS. So even though this effect isn't created in SVG filters anymore, the effect is still visible in SVG, so that's why I have it as my final example. So these are my favorite two blending modes, multiply and screen. And if you don't know it, you can recreate this by setting the mixed blend mode of these circles to either screen or multiply. But it's also very important that you place these circles into a group and isolate them. Otherwise, the background will be taken into account when the color blending is calculated. And you might end up with seeing absolutely nothing on your screen, no error message in the console, and you can't figure out what the heck you're doing wrong. Trust me, I didn't know about that isolate property for a long while, and of course I was experimenting with screen on a white background, so I was seeing this. And although I didn't try it, if I would have done multiply on a black background, I also would have not seen anything. And I was sort of ready to give up for a while until I came across that isolate property. Well, being an astronomer, it's all these self-taught things, so it really depends on what the internet teaches you. But that saved my day. So how do I now apply this in data visualizations? Well, I tend to use them in cases of minor overlap. So here we have a very busy line chart of the average daily temperature of 8 cities in 2015. And I just wanted something that was very busy, and I made the lines extra thick. But why should Amsterdam always lie on top of, say, New York or Cape Town just because it was plotted later? I mean, all of these cities are equally important, so that doesn't seem fair to me. And then usually people sort of go to opacities. But I don't want the lines to be any less visible when they are not overlapping. And although the opacities creates a bit of a blending, Amsterdam is really still the color that lies on top. So I give these lines a multiply blend instead. And now when there is a point where they are overlapping, you can't say anymore which one is really on top of the other. And also the niceness of the color blending, it creates a sort of extra something to the visual. I find that that's an interesting thing to look at. You can also use this for circles, but only if they are not completely overlapping. So some of the true color still has to be visible. And here we have a completely random slope graph of animals, where we have some partially overlapping circles. And again, in some places we have the same issue as we had before in the line graph. In the top left, we have a purple giraffe that is blocking a red deer. But again, these animals are equally important, so that's not really fair. Why see more of the giraffe than the deer? So again, I give them a multiply blend instead. And now it's not really visible which one is lying on top. And again, sort of a nice visual touch that makes this a bit different than the others. But I guess maybe this effect shines best when used in some form of data art or generative art. So as my very final example, I'll show you something that I can look at indefinitely. And the color blending really makes for a nicer result, because if I turn it off, we get this, and I say that definitely has less magic. So I hope that some of these examples might help you someday to create an even more fun or effective visualization. And I hope even more that I've inspired you to always go beyond the norm, so that you have to make as few concessions to the computer as possible in your quest to recreate the image in your mind. And of course, I hope that you'll go beyond the shapes. Well, you can find all of the underlying code and long explanations in the 10 tutorials that I wrote about all of these techniques on my blog. And thank you very much for your attention.